Good afternoon and good day for everyone, and warmly welcome to this Metsä Material Efficiency webinar. And first of all, I would like to introduce today. In here we have I'm Jyrki Uimonen, Sales Development Director Metsä Kerto Sales, and also here is my colleague
Janne Heikkilä. Hello everyone. I'm responsible for technical customer service for Kerto products. Jyrki will continue now.
Thank you. All right. Today we are going to speak about material efficiency in the construction sector and in industrial sector, and then we are going to speak and introduce our Kerto LVL products, typical Kerto products, the portfolio, designing values of Kerto, and let's say mostly the structural examples for the single-family houses, multi-story buildings, and also for industrial applications. And in the end of this webinar, Mr. Janne Heikkilä will tell more about Kerto Ripa, meaning the structurally glued the elements, these vertical elements and wall elements, material efficiency more deeper. And after this, our presentations, and of course during the whole webinar, you can send the questions. We will answer for these questions after our the material. First of all, we start from Kerto products, and before that, I would like to take some minutes to tell some basic information from our company. We as Metsä Wood, we are part of the Metsäliitto cooperative, which is one of the biggest cooperative in Finland. And what this actually means? This means it's very secure raw material availability, high quality raw material for our wood products. And of course, behind our cooperation, Metsäliitto cooperation, are bit over 90,000 Finnish private forest owners, which own almost the half of the Finnish private forests. So in that way, the raw material availability for the Kerto products, for example, is very well secured. And also, I would like to highlight that we as Metsä, we have manufactured and developed our Kerto LVL almost 50 years. We started Kerto products developing and manufacturing in year 1975. So more or less almost 50 years we have been in this business with our Kerto LVL products. But now we are going to more deeper to our products and the products applications, and especially the material efficiency regarding the Kerto LVL. First of all, when we think about the building sector in generally, it's very well that let's say we can see more and more the wooden buildings and the wood products in different kind of buildings. But in other hand, we have to make sure that the constructions and the buildings are built with sustainable way, that we use our raw material as wood as efficiently as it possible. Meaning that when we look to the coming years and coming decades, we have to secure the availability of wood and the wood products. And the Kerto LVL provides one of the highest material efficiency for different kind of the structures. First of all, when we start looking the material efficiency, we start from the production efficiency. And Kerto LVL, the laminated veneer lumber, as called, it's produced from 3 millimeter thick softwood veneers, mostly spruce, and these veneers are glued together in the hot press line. And the production of LVL makes and is one of the most material efficient the wooden construction, the material. And typically on the modern, the LVL manufacturing process, typical yield range is between 2.4 to 2.6 on over bark on the logs. So this means that the LVL and Kerto LVL is one of the most efficient products, wood product, when we look at the production, the perspective. And for Kerto products, the primary raw material is spruce, and the small part of the veneers are the Nordic pine. And the Kerto LVL process, it's process, and it's as a continuous billet, the layup process in general. Secondly, let's say the key driver for material efficiency from production side and the production efficiency are the design values. LVL and Kerto LVL based for veneer structure, and this eliminates the impact of the all kind of natural effects as knots, splits, and most of the typical wood mechanical defects. It means that this veneer layup spread the defects overall and a wider area of LVL billets. And this is a very big difference, for example, for timber products. The impact of the one knot in the timber products, it typically goes through the product. But in LVL, in Kerto, the impact is only in 3 millimeter the veneer. And secondly, this means that this veneer structure creates the path for very high design values, meaning that because the LVL products veneer structure is very homogeneous, it means that this product, Kerto LVL product characteristic properties are generally in 2 times higher comparing for typical the timber products. And this means that these Kerto LVL design values can be utilized in 100%. So product bending requirements, bending properties can be used in 100%. Thirdly, the veneer structure is split the defects on the wider area, and at the same time that strength, the weight to ratio of Kerto LVL is extremely high, and it means that more or less the same as steel in proportion in weight. And Kerto LVL is one of the lightest the LVL product in globally, and the Kerto LVL offers for designers very light, slim, and extremely durable structures, which normally means that the less material is needed for construction square meter. Less cubics from base material, more squares or volumetric cubes in the constructions. So this was the second driver, design values. And here we can see on this chart, we can see our main products, Kerto S, Q, T-Stud, and L-Panel. So we have the main product groups, main products, which under we have some sub-products. But Kerto S is typically the beam products. All veneer layers are in the lengthwise, and let's say main designing value for structures, the bending strength in edgewise is 44 Newton per square millimeter. Secondly, we have a Kerto Q panel, which both with Kerto S are the high density products, and it's LVL 36C according the European LVL the classification. Bending strength in the edgewise 32. And then we have the light products, Kerto L, panel product for modules, bathroom bots, many slightly load-bearing structures, panel type produced from light veneers as a Kerto T. And these are, let's say, the main design values, design properties, what we can see here. So very strong and very light product in generally. Third driver is actually comes when we look the material efficiency from the product features and especially the dimensions. LVL is dimensionally very stable, and it's free of the warps and splits, and this comes from the veneer structure. And the Kerto LVL products are manufactured to exact dimensions. Of course, we have, let's say, the typical stock items, but normally when we think about our customers, the business, let's say customized, tailor-made products, and the dimensions typically are the way of material saving. So that way, these two kind of product types are available. Kerto LVL final product, the dimensions are available from small section items to large scale panels and beams. And when looking back for the production side, I must remind that in Kerto LVL, product dimensions are one and only product type where the final product dimensions are not linked directly to raw material dimensions. And in same time, in our process, we can use very small section, the peeling blocks to our Kerto production. And this means very high material efficiency. And Kerto is easy and very easily workable and light material, which means the substantial time and the cost savings in the construction side. And no need any special tools for Kerto material processing. And product range, Kerto LVL products are thickness from 21 millimeter to 75. And then later on, when we are starting up our new factory, the 90 millimeter will be also available. And also, in addition of these Kerto typical products, we have the special roof panel products, Kerto Kate, 15 and 18 millimeter, which are designed especially for the roof structures under different kind of the surfaces. So the green construction with the Kerto LVL. The summary from the first words. So cost efficient, long free span with less material consumption. less cubes for more squares or longer spans. Customized product dimensions with minimum waste. Less waste also means that there is less need to transport. And of course, more payload for trailers and so on. And of course, the material speed up the industrial prefabrication construction process. Easy to build, lightweight, and excellent workability. Kerto LVL provides very wide the product portfolio. As we just looked from normal beams, the high density beams, high density Q panels, to light product Kerto T and L for non or slightly load bearing the structures. And of course, the scaffold planks for the scaffolding the constructions. Couple examples of Kerto LVL products for typical single family houses. When we start from the top, we have Kerto Q panels for Kerto for the houses, the roofs. It can be the small size. It can be on the big size. Maximum size 2.5 times 20 meter per panel can be the possible. Then for normal single houses, the framing, the timber frame walls, Kerto S used as the frame beam, or in the lintel, or in the main beam, main header in under these the rafters in the roof structures. Wall stud, Kerto T, or in load bearing parts, Kerto S. And then of course the rim board, Kerto S, and as well the floor joist. And then in the bottom we can see rig-glued Kerto Q product. We call it, the name is the Kerto GLVL. And it's due to the very high compression strength. It's very good application for single family house, but especially for a multi-story building, these lower core parts. These are the typical examples for the single family houses. And taking the one shot from that previous slide, I would like to present this, let's say, one of the, let's say, the mostly used parts of LVL in the structural applications. It's a lintel, and it's typically used the beam over the windows, over the window areas, or the doors. And like in this example, it can be Kerto Q, it can be the straight panel, the beam, or it can be this kind of L-shaped. This example part is actually screwed, but the product can be straight beam, or this L profile can be also structurally glued. This is just one example where LVL and Kerto LVL, the beams can be, let's say, utilized very often. And then on the last one is the Kerto LVL applications for multi-story houses. The same product types from roof panels to S beams on the roof structures, then S and Q element structures in slabs, and then of course Kerto Q panels and GLVL on these elevator towers can be used as well. And also in balcony, what is a little bit special area, Kerto Q panels, Kerto GLVL with very careful the water protection in the outside. And these are the typical product types for the multi-story houses. But now time is running, and now time is that Janne will tell more about of our Kerto Ripa, the different element types, how to use the Ripa elements, and the Kerto Ripa material efficiency. So, please, Janne.
Thank you, Jyrki. Okay, so Jyrki told about production efficiency, the material efficiency, and the product efficiency. Now, I'd like to introduce our element application, which is called Kerto-Ripa. That was the development started roughly 20 years ago, and we actually produced those elements by ourselves. But after disinvestment of the project business, we don't produce those elements anymore by ourselves, but instead of Metsä Wood, our selected partners are producing those elements. But what is Kerto-Ripa all about? So it's a CE marked composite slab element, and it's made of Kerto LVL components. The structure is put together with the structural PU gluing, and what is special in Metsä Wood solution is that the gluing pressure can be organized either with the screws but also with the nails, which makes the production very efficient. The product element is ETA assessed product, and we still have the production ETA. So we are talking actually in Metsä Wood, we are talking about production technology that we are offering to our selected customers. And we provide them with the possibility to apply their own ETA by using our Metsä Wood ETA. It provides kind of a shortcut or short track from a decision making contract with us to actually start the production. In best cases, that happens in 6 months. But if you start from the very beginning, from the scratch, it means that it takes a lot of time and money to develop that kind of a product. And then the last bullet, Finnwood design software. This is something that can be downloaded from our web pages, and it's free of charge. And you can calculate the right cross section and a type of element with Finnwood software. There are 4 different types of Ripa elements. Starting from the left-hand up corner, there's a Kerto-Ripa box, which is a full box element, and it's normally used with roof applications, but also can be used with floor structures. Then there is an open Ripa box, which is mainly used with the floor structures. It enables all different kind of installations within the element structure itself. And on the right hand, there's open T, which can be used with so-called cold roof structures, like for garages or something like that. And then there's an upside down solution, which enables on construction site happening installations, like running ducts and electricity in that floor structure, and installing installations on construction site, and afterwards then you install a board on top of that structure. What are the benefits of Kerto floor elements, Ripa floor elements? It's first of all, it provides a solution as a dry structure. So it doesn't call for any concrete casting on a construction site, but for instance, the sound insulation can be organized with gypsum boards, like in a picture on the right hand in the middle. So there's a floating structure made of gypsum boards, and which enables to reach the required sound insulation level. It reduces the story height, and what is special with the Kerto-Ripa element is top slab connection. So the upper slab actually works as a supporting structure, and that is something which eases the construction work on the site. It enables long spans as well. The structure itself is very stiff thanks to the structural gluing. I'm going to tell more about that later. It fulfills fire and acoustic requirements. It's stated there in an ETA. Currently we can provide 90-minute fire classification for the structure. It reduces the construction time on construction site, and also that is thanks to the very high prefabrication rate of the element. This slide shows how efficient this structural gluing is from the stiffness point of view. This is a case that was calculated by external independent engineering office. The upper one is element is made with a mechanical connector. So in this case, they have used as many as possible nails. The distance between nails is only 60 millimeter, and the thickness is 3.1 millimeter, and which is the maximum thickness with the current rib structure. It's the rib itself is 45 millimeter wide. But putting this structure together with the mechanical connectors doesn't provide such a stiffness as the structural gluing does. In the middle, you can see what would be the cross section as a RIPA element cross section. So it's almost half of the mechanical connected element. And then at the bottom there's a structure that presents a structure that you have only beams or floor joist as a load-bearing structure, and no composite action at all with the panels. And then, of course, this is now designed for or calculated for 5 meter span length only. If you select the same cross section as with the mechanical connectors, then you have a chance to increase the span length, I guess up to 7-8 meters. I haven't calculated that really, but just roughly my gut feeling for that. And then the second application for RIPA elements is roof elements. With RIPA technology, our customers are able to construct 2.5 meter wide elements that are up to 20 meter long. Also with the narrower structure, 1.8 meter, the length can be up to 25 meter. And the span length can be, say, up to 20 meter, which makes it a very efficient solution, or effective actually in this case. The structure can be finalized almost completely at the off-site conditions in a fabric or plant, and then once including all water membrane and insulations and everything. So the installation on the construction site happens very fast, and 1,000 square meter per day is easy to reach. In some cases, even 1,500 square meters can be done. This was the second application, and now we are currently developing the third application with the Kerto-RIPA technology. That would be wall application. We started to think that if we are using for the horizontal structures, so why not to use it for the vertical structures as well, as we know that it's very strong structure, and it's proven to be so also. And the plan is now that we will extend our existing ETA and and provide the design instructions for the new applications so that our existing partners and customers producing RIPA elements can easily then move in a production to the wall structures as well. The idea is to use this for heavy loaded structures, for vertical loads, and for bracing loads. And here's one picture from the test arrangements. We finalized the pre-study at the end of the 23, and now we have actually completed our load tests. In April, we actually do together with the Eurofins, we actually loaded till break roughly 30 different elements under vertical loading and also separately under horizontal load. Like in this picture, it's there on the upper corner. There's a jack, hydraulic jack that is pushing the element from the upper corner. Next steps, we are currently analyzing test results, and test results already now can be said that these loading tests has proven what we have in theory calculated, and so we have really been able to develop a product that is very stiff and strong structure. Design instructions will follow, and also we will then target this to finalize the ETA during or latest in autumn this year. Here's a very simplified example of what is the load bearing capacity of this element, and with that kind of a 2.4 meter wide and 3.2 meter high element, which is made of a Kerto Cube panel 25 millimeter with ribs made of 45 times 195 and with the spacing of 600. That element is capable to carry 82 tons, and this is a characteristic value. So it really gives you an impression that actually you can put a heavy truck on that wall and it can carry that load still. So maybe it's not overkilling to say that overwhelming load bearing capacity. All right, that was about Kerto applications. Then I'd like to introduce a conceptual wooden plogo flats. That was a case study which was done by external engineering office, Bjerking AB in Sweden. This imaginary building was designed with Kerto LVL, one option with Kerto LVL and the other one with CLT. And that was designed according to Swedish regulations. It's 8-story high residential building. The floor plan is 20 meter by 16 meter. And the load conditions or environmental conditions were selected from the Stockholm area. And how does it look like then? On the left hand, you see the floor plan. Now, if there are architects, please don't pay attention about this architectural design. It's just a showcase from the structural point of view. So on the left hand, you have a Kerto LVL solution. There you see that actually all load-bearing structures, outer walls and internal walls are presented in the picture, and these arrows there are showing that to which direction the floor element is actually carrying the loads. And the floor elements are made as Kerto RIPA elements, and wall structures are made with the solid Kerto Cube panels. I will come to those structures later. And on the right hand, you can already see what is the difference. If the floor structure is designed as a solid CLT panel, you need additional load-bearing walls, internal walls, which means that you need more wood already now, and also that you are losing some flexibility in design. Here's the wall structure. LVL, left hand. There are two different types of structures, and the load-bearing part there is a 69 millimeter cube panel or 84 millimeter thick cube panel. And the right hand for CLT, it's all around 120 millimeter. The total thickness of the wall structure is thinner with Kerto LVL, which leads to more sellable square meters with Kerto LVL. Apartment dividing partition walls, that's also made with the Kerto LVL as Kerto Cube Panel 69 and 84, and once again with the CLT 120. So I need to tell that also for these apartment dividing partition walls, the sound insulation requirements are fulfilled with this structure. So they are checked as well also fire classification. And then here's the trick. With Kerto LVL, there's no need for that additional internal wall. Instead of this CLT 180 millimeter thick CLT wall structure. That is completely missing now with the Kerto LVL. Floor structures, RIPA element on the left hand and CLT on the right hand. Total thickness of the structure is roughly the same. What is recommendable or what is notable with the Kerto RIPA element is that you can actually run all installations like ducts within the structure itself. So in the best case, you can actually install those ducts already in off-site conditions. And then finally, I would like to introduce one reference case. So from the theory to the practice, this is an example from Norway, Verksbuen. It's an area where sustainability living area, and it's planned to be home for 5,000 people in next 10 years. 2019 and 25 five-story apartment buildings were constructed by Arkanova Bulik, and these buildings were constructed out of Kerto LVL. What is remarkable here is that actually, like the right-hand bottom picture, you can see there's no load-bearing walls in the building except those ones which actually are bracing walls. But otherwise, all the floors are supported by outer walls. So from all elements which are Kerto RIPA elements, they are supported from the outer walls, which leaves the space between the outer walls completely open and provides a total flexibility in floor plan design. About the outer walls, three first floors are done with tube panels, 67 millimeter thick ones, just like in a previous example. So solid tube panels. The upper two floors are made with studs. The span length is quite big. It's 9 meters from outer wall to outer wall, and that is only possible with the Kerto RIPA elements. With the solid wood structures or single beams, the thickness of the structure would increase or become too thick, which is not economical and not maybe wise. In that sense also that there is a city plan, there's a restriction what can be the maximum height of the building, so you might even lose one additional floor with the thicker floor structure. The Kerto elements, they don't just take the horizontal load, what is the floor load, but also it works as a, it forms a stiff plate because the elements are connected to each other, and this stiff plate transfer horizontal loads from the wind to the bracing wall structures, which are at the end, the outer wall, and also in between, like I mentioned, those walls. Sound insulation can be or was organized with the fiber reinforced concrete casting that was cast on an impact sound insulation board on top, and then there was a suspended double layer of the gypsum boards underneath the element, which also worked as a fire protection. So the floor fire classification is 60 minutes. And like in the picture, you can see these men are currently installing ducts within the floor structure, and that is thanks to the open box element type. Can be easily done on construction site. And also need to say that what is one benefit using Kerto LVL is that you can actually do 50%. You can do big openings in web in this rebar element, so that the size of the round web. Round hole in a web can be 50% of the total height of the web. All right, that was my presentation. Thank you for listening. And now it's time for questions. Otatko sä, Jyrki, tuo?
Joo.
Okay.
Okay. All right. Thank you, Janne, for your presentation. And as we discussed that, we are looking these questions. Thanks for your activity and the questions. And first of all, there is a question regarding our raw material, what we use. Kerto LVL is primary. The species of the wood is Nordic spruce, meaning about 95% of the veneers are typically spruce, and rest of the 5% are the Nordic pine. These are the softwood species what we use for Kerto LVL. Then second question comes, and the question is that can you provide the presentation to participants after the webinar? We will do, let's say we have some kind of the material package where we can install, let's say the part of this presentation, but most of these topics we can send as a presentation for you participants. And then Janne, maybe you take next one.
I guess that was the only two questions so far.
Correct, actually the same question regarding the materials. Yeah. So good. Currently we see these two questions. If you have any other ones, you can send those afterwards. And of course, after this presentation, where the contacts, where you can, if you have any questions regarding these Kerto LVL products or Kerto elements, you can take the contact. Oh, okay, actually one.
Yeah. One question popped up. How optimize beams plus panels combination for floors and roofs? What is the status of development for bio-based glue in LVL lamination, and how does this compete financially with the standard? The first question, I would say that optimization with the beams and panels happens case by case, and it happens by a structural engineer who is designing the structures, who is in charge for the structural design of the building. So there's no, let's say, general answer to that question.
And the second part is what is the status of the development for bio-based glue in the LVL lamination, and how does this complete financially with the standard? Regarding this, we as Metsä, we are developing our bio-based the glue as well. It's in process, but at the moment, unfortunately I cannot say what is the impact of LVL lamination. Is the negative or positive? It's too early to say, and also these financial aspects are too early on this stage. But we are developing our bio-based glue at the moment. Yeah.
Okay.
So these were the questions. I think that it's time to summarize this meeting and the webinar and close the lines. We thank you for your participating of this webinar. We hope that this will give more information of our Metsä LVL wood products, its applications in structures, element structures, and coming new element structures as well. And of course the LVL, the properties dimension in generally, and what mostly, what is the way for more material efficient the buildings now and in the coming years. So thank you.
Thank you.